This is Catherine Schmer at Chattanooga State Community College. This is video 3 of Lines in Space. In this video, we'll be talking about whether lines are intersecting, parallel, or skew, and how to tell. So lines can be intersecting, parallel, or skew. They can either intersect at a point, in which case it would look like two lines crossing at a single point. They could be the same line, in which case it would look like you have one line. They can be parallel, meaning that they never cross, so they have the same direction vector, or the direction vectors are scalar multiples of one another. Or they can be skew. So two lines cannot be skew in 2 dimensions, but in 3 dimensions, if the lines are neither parallel nor intersecting, then they're considered to be skew. So we want to know how to determine whether a pair of lines is parallel, intersecting, or skew. And if they intersect, we want to determine the point or points of intersection. So we're given the lines lowercase r of t equals the vector equation 8 minus 4t, 3 plus t, 2 plus t. And capital R of s, so we're using parameter s here, equals the vector equation 2 plus 2s, 1 minus s, 14 plus s. So the first thing we're going to determine is whether they're parallel. So we need their direction vectors for this. So in this line, the direction vector is negative 4, 1, 1. So I'm going to call that v sub 1. And remember, that's just the numbers attached to t. In capital R of s, v2 equals 2, negative 1, 1. And remember, those are just the numbers attached to the parameter s. So now our first step, check to see if they have the same direction. The way we're going to do that is by seeing if the direction vectors are scalar multiples of each other. So I can look at these and I can see that, I can look at v1 and v2 and see that there's no number that I could multiply v1 by in order to get v2. If I tried to multiply negative 4 by a negative 1/2 in order to get the 2, then that would not coincide with changing from the y value in v1 to the y value in v2. So there's the direction vectors v1 and v2 are not scalar multiples of each other, and so the lines are not parallel. So it's an easy check to see if they're parallel. You just find the direction vectors and see if there's something you can multiply one of them by to get the other one. Now if the answer to number 1 is yes, they're parallel, then you check to see if they're the same line. If the answer to number 1 is no, so they're not parallel, then you check to see if the lines intersect at a single point. Now to do this, we're going to set the vectors equal to one another. So I'll have lowercase r of t equals uppercase r of t, and we do this component-wise. Remember, if two vectors are equal, then their x components are equal, their y components are equal, and their z components are equal. So I'm going to have 8 minus 4t equals 2 plus 2s, 3 plus t equals 1 minus s, and 2 plus t equals 14 plus s. So just component-wise, x equals x, y equals y, z equals z. Now I want to solve this system of equations. So I'm going to rewrite it so all of my variables are on the left side of the equal sign and all of my constants are on the right side of the equal sign. So I get negative 4t minus 2s equals negative 6, t plus s equals negative 2, and t minus s equals 12. Now, if you have had linear algebra and know how to put this into a matrix and row reduce to solve, then that's what I would recommend doing. I can't assume that everyone has seen matrix row reduction, so I'm going to show a different way to solve it. And the way I'm going to show is the process of elimination. So I'm going to add the two bottom equations together, and I get 2t equals 10. The s's are going to cancel because I have plus s and minus s. So I'm just adding those two equations together. So that actually gives me t equals 5. So I have a t value. Now I'm going to plug it in to one of the equations in order to solve for s. So I'm going to plug it into the middle equation. T plus s equals negative 2. So 5 plus s equals negative 2. So s equals negative 7. Now, the problem with this is I haven't used the first equation at all in my solution process. And so I have to actually check to make sure that this gives me an equal point for each of the lines. So I have, for t equals 5, I'm going to plug that into lowercase r of t. So r of 5 equals 8 minus 4 times 5, 3 plus 5, and 2 plus 5. So that's my x, y, and z, and that gives me the vector negative 12, 8, 7. Now I know s equals negative 7. I'm going to plug that into uppercase R. So uppercase R of negative 7 equals 2 plus 2 times negative 7, 1 minus negative 7, and 14 plus negative 7. So that also gives me the vector negative 12, 8, 7. So I know that the two lines intersect at that point. So the lines intersect at the point negative 12, 8, 7. So I'm basically done with this problem. However, if I had gotten a non-intersecting answer for this, then if the lines are neither parallel nor intersecting, then they're skew. So it's skew by default if you cannot find a solution to parallel or intersecting. Now again, let me go back to the previous screen. So again, you set up your system of equations by setting the two vectors equal, and if you're familiar with matrix operations, just put that system of equations into a matrix and row reduce, and you'll have your point of intersection.